Hi everyone, let's discuss QOD 9. We have been given one relation a comma b where mod a is less than equals to b. A comma b belongs to R. Now we have to check whether this relation is symmetric, reflexive, transitive or equivalence. Now let's look at symmetric first. We have been given mod a less than equals to b. For symmetric, we'll have to write mod b is less than equals to a, right? Now let's take one example. Let's say a equals to 1 and b equals to 3. Now we can clearly see that for this case mod a is less than equals to b. But reverse is not true, right? Mod b is not less than equals to a. So it cannot be symmetric. We just have to find just one case for which this particular relation doesn't hold. And we have found that case. So that is why it's not symmetric. Now let's look at reflexive. We have mod a less than equals to b. And for reflexive, we'll write mod a less than equals to a. And again, this is wrong. Let's say we have a as minus 1. In that case, mod a equals to 1. 1 is not less than equals to minus 1, right? This is not true. So that's why B is also not true. A is not true, B is not true. Now let's look at the transitive case. So the first condition is mod A is less than equals to B. And for transitive, we'll have to write mod B less than equals to C. Now let's look at this one. If this is true, if we just consider these kind of elements. So what we are talking about, we are talking about elements like this, where A is 2 or minus 2 and B is 3 or B is 2 or A is minus 2. We are talking about these kind of elements, right? Now we can clearly establish that B is greater than equals to 0 because this is a positive value, right? So we can clearly say that B is greater than equals to 0. Now if this is the case, we can write mod B as simply B. So mod B is less than equals to C. So basically C is even bigger than B. If mod A is less than equals to B and B is less than equals to C, that clearly means mod A less than equals to C, right? That's what we want. If this is true, then this should be true. This is the case for a relation being transitive. So that is why C is transitive. This relation is transitive, right? And it's not an equivalence relation because it's not symmetric and reflexive. So C is the correct answer.